Okay, welcome back to part 5. So in this part, we're actually going to do the heavy work of writing the parser. And then while it might seem like a somewhat daunting task, it's actually pretty straightforward. We're actually just going to kind of reuse the same logic over and over and over again to write our parser. So as we mentioned, there are really kind of 4 things that could exist in a line of assembly, right? We have a label, we have an instruction, we have comments, we have white space, but it's a little more nuanced than that. So there's really kind of 4 different tokens that we mentioned, right? A label, an instruction, and potentially a first argument and a second argument. And they will present themselves in that order. So we should process them in that order. So the first thing we're going to do is get a label. Now, we don't know if we have a label yet, so we'll have to detect that. So the way we're going to detect that is to say, if the first character of a line is not a space, and the first character of a line is not a tab, our 2 white space characters, then we must have a label. And so we're going to need some sort of variable to represent the end of that label. So I'm literally going to name it nLabel. Like I said, I'm a very, very creative variable namer. One of the nice things about D is I don't have to say equals 0. If you just declare a variable, it automatically will get initialized to 0. Nice and safe. So what we need to do now is we need to write a for loop to iterate over our line and to stop us whenever we've hit what must be the end of the label. So that could be any of our end of token characters, or of course it could be if we reach the end of the line, right? If we've reached the end of the line, then it must be the case that we're done processing because there's nothing more to process. So we'll say if end of token, or now labels are a little special in the fact that you can terminate them with a colon character when you declare them. So we can check for both. We can check for an end of token character or a colon character. If we see any of those, we must be at the end of the label. So we can say nLabel equals wherever we are in the string at the moment. And then we can use a really handy feature of D called slicing, which is just to say we have a portion of the string, a substring in the string. So we can say the label must be equal to the slice of the line that begins at the beginning of the line and ends at wherever nLabel happens to be. We can then say if line I equals colon, because the colon is not actually part of the label name. It's just the way you can choose to end the declaration of a label. So if we do end with a colon, we should just increment to the next character in the line, since that's not actually part of the label name. And then we break out of our loop. And we're pretty much going to repeat this logic over and over again. So next thing we have to do is go to the start of the next token. So we can say if next, right, which brings us to the start of the next token, is false, then there are no more tokens. So we're done. We can just return. If it does find another token, then for us, it must represent an instruction. So we will say get instruction. And so we'll say the start of the instruction is equal to wherever we happen to be in the line now, which is I as our index. And then it's exactly the same logic. For no initialization, I is less than line length, I++. We're going to iterate through things, and we're going to say if we've reached the end of the token, and we don't need the colon here because you can't terminate an instruction with a colon, just any of the end of token characters. So if we've reached the end of the token, then this must be our end instruction location. And we can say that an instruction is the slice of the line that begins at start instruction and ends at end instruction. And then we can break out. And that's it. And that will get us an instruction. And then it's exactly the same logic. We'll go to the start of the next token, So if next equals false, then we have no more tokens, so we'll return. If we have more tokens, it must be the case that it's the first argument. Now, we don't know at this point if we have one argument or two, but it really doesn't matter. So we'll just say that if we only have one argument, then it's also the first argument. So we'll say start first equals I, and then it's exactly the same logic. So we'll say for no initialization, I is less than line.length, I++. That's also one of the nice things of D. Strings have, all your strings will have a property called length. In C or C++, you might be used to something like a strlen function, but in D, it's just a property of strings. So you can just say line.length and get the length of your string. So we'll say for I less than line.length, so same logic. So we'll say if we see an end of token character, or as we mentioned before, if we have two arguments, then they'll be separated with a comma. So end of token character or comma character, we must be at the end of our first argument. So first will just be the slice of the line that begins at start first and ends at end first. As you can see, the logic is really straightforward. Once you kind of wrap your head around it for one of these tokens, it's exactly the same thing for all of the other tokens. But we are going to end with the same thing like we did with our labels. If we happen to see a comma at the end of our first argument, the comma is not actually part of the argument, it's just separating the two arguments, so we'll just skip right on by it. And then we're going to do exactly the same thing. We will say we need to go to the start of the next token, and that would be if next equals false, we'll return. Otherwise, we'll get the second argument. And by now, I think you know what we're going to be doing. We'll say we'll have a new variable called, we'll call it start second. And we'll make that equal to where we are in the line at the moment. We'll then have our for loop. Oops. We'll have our for loop. And we will say if we see the end of any of the end of token characters, we will perform the logic to end a token. And by now, you should all be pros at it. It is exactly the same. This slice will be from the beginning of start second to the end of end second. And then we break out of our loop. One last thing we can do for sanity checking is say, well, at this point, we have our 4 tokens. And that's the maximum number of tokens that we can have on a line. So we can check to make sure that that's actually true. So in this case, we can say if next equals true, right? Because here we want next to actually equal false. But if next happens to equal true, then we should error out. Something is wrong on this line. And the way we can do that is by saying throw new exception and then give it some sort of error message. So I'll just say found extra tokens. That works. Exception is an object, so we'll initialize it with new. And if you remember, for those of you who are new to this, this throw language is the metaphor for catch, right? It's baseball or whatever other sport you like that has someone throwing a ball and catching a ball, right? So the catch catches the throw, and when it catches the throw, it prints out an error message with whatever message we put in and whatever line number we happen to be at, and then returns a 1 to let the user know programmatically that there's been an error. And that's it. That's our whole parser. So I would invite you to kind of sit with this, particularly if this logic is new to you, and see if you can parse out. You only need to do this for one, right? So pick a label, an instruction, the first argument or the second argument, parse through the logic, make sure that you understand what the logic is doing, and then it's exactly the same for all the other ones. And that's really all we need to successfully parse any of our lines of assembly. So I'm going to save this. I'm going to commit, wrote parser. And before we conclude this episode, I'll just mention that you might have seen other places where I'm making assumptions as to what our lines of code are going to look like. For example, I'm not allowing for the possibility for there being a space before that comma if we're separating two different arguments. So when things like that happen, they'll become what we'll call homework assignments. So for homework, you can think about how you might implement the ability to have, let's say, a space in between the end of the first argument and that comma. So you don't have to do it. I'm not going to do it for this workshop, but it might be something for you to think about as you grow in your skills, extra niceties to have in our assembler. All right, with that, I'm going to conclude this episode, and I will see you back on the next episode.